Okay, so on this one, it talks about the first question says, with a margin of error of 5% and 95% confidence interval. Okay, so what that confidence interval means is, like if I had, uh, let's finish reading the sentence and I can go from there. A recent poll claims that 47% of Americans support the president's policy towards broccoli growers. So what we have is we have this like confidence interval, okay? And it says it's plus or minus 5%. Okay, so it has an error of 5%. So really plus or minus 2.5. So we have this uh, confidence interval, and here's 47. Okay, so plus 2.5 and minus 2.5. Well, we don't even know that 47 is the middle of it. We just know that I have, it doesn't even tell me what my confidence interval range is, but it just says a recent poll claims that 47% of Americans support the president's policy towards broccoli growers. Okay, so what that confidence interval means is that I have like two numbers, a top and a bottom. So the bottom could be 46 and the top could be 51, or the bottom could be 45 and the top would be 50. This is my error, okay? Or the bottom could be 48 and the top could be 53, or I think you get the idea here. But then I have all these numbers in between, okay? So 95% confidence interval means that I am, like if I had 100 numbers, okay, and they were between whatever one of these we said it was. So if I choose this one, if I had 100 numbers, 95. Hold on. Let's say I take a sample. This will make more sense. I have a sample of 100 items. Okay, I take this sample. I find that out of this sample, I find the mean that are in favor. Okay, I find the mean that are in favor of broccoli growers. Okay, so I do that this time. I do it again. So I do it another time. New sample, new 100 people, and I find the mean. And I do it again, and I do it again, and I do it again, and I do it again. I keep doing this. Say I do this 100 times. Okay, so I've taken it. I've taken the sample 100 times from 100 different people. Okay, so I've sampled 100 groups of 100. So from that group, from those 100 groups, I could take the mean of all those means. So like, say this first group, they were 47% in favor. The next group were 49, and the next group was 51, and the next group was 45, and the next group was 48, and the next group was 50, and the next group was 53, and then I have a group where their families grow broccoli, they're 68%. And then I have a group that for some reason I surveyed 100 elementary kids, somehow that popped in, and like, yeah, broccoli, and they're 25%. So anyways, I take 100, I do this 100 times, and I get 100 different means. Okay. Well, from those means, I could calculate the mean of the means if I wanted to. Okay, that would give me a pretty good value. But what a confidence interval is saying, so when I talk about confidence interval, I'm saying that if I were to take and do this forever, or if I were to do it for the whole population of the United States, that the true mean for that whole huge population is between these two numbers. I am 95% confident that if I were to take the population of the whole United States, the true mean is actually between these two numbers. I'm 95% confident that that true mean is between these numbers. Okay, so I could be 5% up or 5% down either way. So, I could be down to 40 or up to 55, really. I'm an error of 5% one way or another from the true mean. So, so that's kind of the idea of a confidence interval. So a confidence interval is just saying we are 95% confident that if we were to actually take the mean of the whole great big population, we were to take this, every person was able to respond, the actual mean would be in this, between these numbers. Okay, so that's what a confidence interval is. It's like, okay, between these two numbers we really will have the true claim for, or the true proportion of people that really support the president's policy towards broccoli growers. Okay, so anyways, that's a confidence interval. So it says in the recent poll claims that 47% of Americans support the president's policy towards broccoli growers. The next week, the poll shows support is now 51%. Should broccoli growers jump for joy? Not really. I mean, based on this 5% margin of error, we would expect that if you were to keep on taking this from different groups, 95% of the time they're going to be within this range. Okay, if I do it again next time, it could be that I could come up with 46%. And if I do it again, I could get a 49. If I take another group of people, I could be 50. So 95% of the time, I should expect it to be within this range. So it's not, we're not saying this is the absolute one, nor are we saying that this is the absolute one. We're just saying that if I were to take different samples, those samples are most likely going to fall within this confidence interval, because we don't really know what the true mean is, but we know that it's somewhere in here. And so when I take different samples from different group, or from different groups, then yeah, it's not going to be exactly the same. Kind of like I said, if you have one that's got a bunch of kids in it that have eaten broccoli somewhere and they really disliked it, then yeah, it's going to be way lower. Or if you have somebody that's like, we should eat healthy food, and you go to that place and you take the survey of that people, it's going to be a little bit higher. So anyways, your your percent is going to change based on each time you do a sample. So anyways, that's what a confidence interval is. It's just saying, we know the true mean is somewhere in here. If I take a different group, it's going to be a little bit above, a little bit below, somewhere in that area. Okay. All right, the next question says, suppose you flip a coin 50 times and get heads only 20 times. Do you think your coin is fair? 20 out of 50, that's 40%. We're starting to get to the unlikely stage. It is possible. We could actually go through some statistics and show you, is this how unlikely is this? Okay, we can actually use a binomial calculation and do some things. So, but for what you guys need to know for this is 20 out of 50 times highly unlikely. Okay, is that on the verge of extreme? Our expected value, we should expect 25 coins to be heads, right? So we're saying five flips really is all that's the difference here. We're saying 5 coins difference of getting heads. So is that very far off from 20? You're probably not too far off. We could, like I said, we can do some statistics and get it there and look at it more precisely. But anyways, that's probably not that far off. Do you think your coin is fair? Most likely. Now, if I were to do this 100 times and I only get 40 heads, then I'd start to probably think it's a little bit more. And if I do it 1,000 times and I only get 400, then I definitely know something's off. Because as my number gets bigger on the bottom, we should get closer and closer to the expected value, that expected probability. So out of 1,000, I should be right around 500. I could be above or below. I could even be 480 out of 1,000. That's still 48% of the time. That's not very far off. But it's hard to tell with smaller numbers if it's very far off. But as it gets bigger, 400 out of 1,000, that is a ways off. Okay, that's probably saying that coin's probably something altered to it or something like that. Okay. So it says you want to conduct a survey of students on the topic of more ice cream in the dining hall. If you want a confidence interval of 95% with a margin error of 5%, how many students do you need to survey? So let's talk about that. So kind of like what I was mentioning before, we can get in some in-depth statistics, and I really don't want to do that for this. There's a kind of a simplified formula in here in chapter 9, section 4, that says if I want to find the percent, like the margin of error, that I can just take the percent. I can take 1 divided by the square root of n, and n is going to be our population size. So I want my margin of error to be 5%. I'm going to go 0.05 equals 1 over the square root of n, not 2. So now, if I want to get rid of the square root of n, like my math skills say that to get rid of a divide by, you multiply each side by the square root of n. So now what I have is the square root of n times 0.05 equals 1. And so now to get the square root of n alone, I divide by 0.05. So I go to my trusty calculator. So I go to my calculator and I go 1 divided by 0.05. And that tells me that it's 20 if I look over here on this screen. So there's the 20. But that's what the square root of n is. So now I need to square it. So I am just going to square the answer. And it says I need to have 400 people. Okay. So that's kind of a quick formula. So it says we need to have 400 people or 400 participants, and that will give me that. So suppose you survey 10,000 voters on an important national issue. What is the margin of error corresponding to a 95% confidence interval? So again, the margin of error, it doesn't matter about this. It matters about this, the number of people we take. So 1 divided by the square root of 10,000. So again, I can just go to my calculator and go 1 divided by the square root of 10,000. And that's a 0.01. So meaning that that's a 1% margin of error. Okay. So I really think that if you're going to read a section, you really should read section 9.4. There's not a whole lot on your final about this, but what this really does is it talks about statistics and how we really use them to in everything. But we really use this idea in the court system. When we have somebody on trial, we always hear, the the people trying. So you have the prosecutors and you have the defense. Defense is always saying, you need to be, um, you shouldn't have any doubt. If you have doubt, then you shouldn't convict this person. Or if you have reason to believe that this person didn't do it, you shouldn't convict him. But it's really hard to be 100% confident on anything. Okay, so when we're talking about court cases and things, we really use this statistics idea. You know, we don't have to be 100% confident. What we have to say is, based on all of the evidence, does it lead us to believe that this person did it or that they didn't do it? Okay. Most likely, we're waiting for the prosecutor to present evidence to say this person, to lead us to believe that this person did it. And so that's what we're really looking at. Um, and this chapter has some great stuff in explaining that. It even talks about like Hamilton. A lot of you have watched the musical or listened to the soundtrack, but it has an article about Hamilton and the Federalist Papers. You know, some papers that were written uh, about it, the kind of the United States. Um, what's the right way? Um, degree. It talks about the liberty and different things, but it's talking about the United States Constitution. There's what I'm thinking of. So it talks about how they can figure out who wrote them because they didn't really want to put their names by them, so they used a pseudonym and or a pseudo name, false name, and they. So, anyways, you really ought to read chapter 9, section 4. Give you some idea about statistics in general. Okay, um, it doesn't. It kind of develops the big idea without going into the heavy math parts. So, anyways, hopefully that's helpful. Um, and then I'll go over some of the other practice problems before you take a final. So, good luck with that, and watch the next problems as well.